Hey, so this video is how to solve example 2.4 and page 40 of the textbook 4th edition using the TI-83 versus the Casio or MATLAB. So it's asking you to calculate the half power beam width and the first null beam width for these or for this normalized radiation intensity. So to do that, we know it's cosine squared theta cosine 3 theta. So we need to punch this into the calculator. There's a couple ways to do it. I found the most intuitive way is to use this y equals, and then you enter in here. So I'll just clear it out and show you the command. So cosine x for theta, this x here, and then it's squared times cosine 3 theta, also squared. And then we want to put the half power point down, so you enter in 0.5 on another plot, so it'll just be a line straight across this function. And then click graph. One thing to note, my units are set here in mode. I have them set to radians right now. And then additionally, my window, I set x min as negative pi and x max as positive pi. And then my y max is 1. So if we click graph, it'll spit out these lobes with the half power point shown across the middle. So to calculate this point, we need to find the intersection here. So we click second calc and then intersect, so 5 for intersect. And we need to find this intersection point. So it asks for the first curve and the second curve, so which two lines basically are intersecting. So we choose, you can just click enter, enter, because there's only 2 curves shown, so enter that, and then this one for the straight line across, and take a guess, just click enter, and it picks this intersection point. And this 0.25 is the same as here, it's the radian value for the half power point. So you just convert that to degrees and then multiply it by 2 for your half power beam width. The first null beam width, you just need to find the value in radians of the null, which is the first null here, which is the first valley. So to do that, you also use the calc, so second calc, and then minimum, so 3 for minimum. And it's going to ask you for this bound and this bound, so you need to trace over there. So click enter here for the left bound. Now it's asking for the right bound, so I go over to the right side of the valley, enter, take a guess, enter, and it spits out 0.52. 0.52 radians is about 30 degrees, and if you take 30 degrees and multiply it by 2, you'll get your 60 degrees, which is the first null beam width.